Video on finding area of oblique triangles. Again, oblique triangles are triangles with no right angle. Okay, so what I'm going to do is I'm going to walk through the three different ways you can find the area of oblique triangles. And as we've discussed in class, you may find some that one particular formula that you should go to, in which is, if that's the case, then you may have to use law of cosines or law of sines to set it up in the way you want. And you can certainly do that. In this particular video, I'm going to show how all three formulas are used and how you can apply them to the triangle. I use the analogy sometimes that, if there's a nail you got to hammer in, you could hammer it in with a screwdriver or a board or something. But if you want to just grab a hammer and hammer it in, then you pick the formula that is right for the job. But certainly, like I said, you can use the law of sines and cosines to set it up into either one of these tools that you like. All right. So for this first one, we notice that this is a side-side-side triangle, meaning I'm giving only the side lengths. Okay. And in this case, this would be the formula that I would use. The Hero's formula that uses all of these side lengths. Again, remember, side lengths are all in lowercase. Okay. Now, one thing that's striking when you look at Hero's formula is it has this variable s. All right. So prior to finding the actual area, we need to find the value of s. So to do that, we're going to add up all the sides and divide by 2. So that would be, let's see, 11 plus 9. That's a bad 9 plus 10, and you get 30. And we have to divide by 2. So my value of s in this case equals 15. All right. So wherever I see an s now in the second step, I'm going to put 15. All right. So we have the square root of 15, and then we're going to subtract all sides from that 15. So let's see. We got 15 minus 11. Then we have 15 minus 9. Then we have 15 minus 10. All right. So what I've done here is, again, following the formula. It doesn't matter what you call A, B, or C. It's just all the side lengths, no in particular order there. And so then when I put it in my calculator here, I get 15 times 4 times 6 times 5, in which we end up with the square root of 1,800, which comes out to be 42.4. And we'll put a good label on there. Let's see, yards squared. Okay. I forgot to mention, if you want to attempt these problems before I show you, just press pause and you can get a shot at it. And then if you get stuck, just continue playing the video. All right. So let's move on to the next one. So that's Hero's formula. If we have all the side lengths, the next type of triangle we might run into is an angle side angle, or in this case, angle angle side. All right. Now you're probably wondering, if you look at the formula, I need 3 angles here. Okay. And I'm only given 2. But we have to go back in our dictionary and say, all right, all the angles inside a triangle have to equal 180 degrees. So if I add up these angles right here and subtract it from 180, we would find that that particular angle is 67 degrees. Okay. So you will need that to use the particular AAS triangle formula. I want to point out that all of these are the same. It just depends on what you're using, as we've recognized with law of cosines, is that the value here is the side opposite angle A. Okay. And again, we have 3 different formulas here, but it's basically the same formula. Just recognize that you have to have the side length here and the angle opposite that side length on the bottom. The other angles, it doesn't matter which one you have here or there. All right. I would say, of the 3 formulas, this is probably the most delicate one, in which you have to be very precise on what goes where when it comes to the angles. All right. So let's get down to business here. Let's use blue, a little bit more of a colorful look to it. And I know in class I might have written a little bit different. I'm going to use it in this way, but you may have also seen it written as, here, I'll just write it right up here. We might have used like a formula look like this. It's the same exact thing. I just, in my formula sheet, I've written it just a little bit different. I'll put the parentheses around the B here. So in class, you may have seen it written like this. It's the exact same formula. Just I put the 1/2 a squared within the formula, okay? So don't worry about that. Also, I wanted to point out this k value. The reason why we use k here is because if we used a, you might get confused that we're talking about an angle length. So k is just an arbitrary variable that we're using to represent our end answer or the area, all right? So let's get cooking here. So I got 1/2. Here, I'll use this one. We've kind of been using in class a little bit. And I'll bounce back and forth, okay? So we got a squared. Now, again, recognize that if the angle that I'm given has to be opposite of the only side I'm given. So we have this, things have to match up, all right? So we're going to have 9 squared times sine, and I can pick either one. It doesn't matter which one I have where, times sine 57 all over 2 times, and this is where it's important. It does have to be particular, all right? As this has to be sine 67 on the bottom. I cannot be just throw it willy-nilly with which angle I put on the bottom. All right, now, it's important when you plug this into a calculator that you do put parentheses around the denominator, or else your calculator is just going to simply follow the order of operations, and you'll end up dividing this by 2 and then multiplying that answer by sine 67. So if you were going to plug this into a calculator, it's very important you put parentheses around the bottom quantity, okay? So if I type that into my calculator, type it all in, I would get 30.6 as my answer, and that's 30.6 meters squared, okay? If you do use this particular formula here, you won't necessarily have to worry about the parentheses on the bottom. Either formula works. It's the same thing. Here, I'll just write it real fast so you can see what it would look like if you were to use this formula. It, again, is the exact same thing, just written a little bit differently. And we're kind of working into that other piece here. All right, so that would be the same exact thing as this, just written in a little bit of a different way, okay? All right, last but not least, we have a side angle side one. And out of all these, this is probably the most frequently used one. And we'll discuss in class how you've been using this the whole time. You'll notice it has 1/2 base times height, which is essentially what we're doing here. It just so happens that when we use it for 90-degree triangles, sine 90 is 1. So we never see this in the original area formula. Okay, so I have side angle side. So essentially all I do is I put in the pieces that I have. So again, k is just an arbitrary variable to represent the area. So we have 10 times 13 times sine 76, which pretty much just takes all the information you're given, and we go with it, and we end up with 63.1 as our answer. If you just type it in a calculator, that is what you would get. Oh, put a label on there, centimeters squared. Okay, so I've shown you 3 different methods of finding the area of oblique triangles. Again, I want to stress the fact that if you like one particular formula, if you like one formula in particular, you may have to use law of sines or law of cosines to set it up in what you want. But like I'll just say, for example, this number 6, if you like side-side-side triangles, you would have to use the law of cosines to find this, and then you can use that formula, the side-side-side triangles. So that's what I'm meaning by that. Okay. Hopefully this video helped you out. We'll be going over it more in class, but please email if you have any questions or come in during flight time. Thank you.